This is our first in the mathematics series from SS1. Today we'll be covering the number base system. Now, what is the number base system? In order for you to be able to know how to calculate or understand maths, you need to understand the English behind the maths. So now I'm going to explain to you what the number base system means generally. Now, think about a base system as a limit, all right, which means you have a particular limit to be able to express something. You have limited tools, in this case, limited digits, to be able to express anything. Now, we naturally use the base 10 system to express numbers. For example, if you have, for example, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we don't have any digit for 10. So we use 1 and 0. It means we are repeating within the same digits that we already have. So if you have 0 to 9, it means you can express any number that there is on earth. You can do 250, 1 billion, whatever, because you have between 0 and 9. And that's why in your calculator you have just 0 to 9, because it is base 10. Why that is called base 10 is because we're starting with 0. 0 is one digit, 1 is, so from 0 to 9 is 10 digits that we have in order to be able to express any number that we can. But imagine a case where you have just 2 digits, 0 and 1. It is called binary, all right? That's the binary system, 0 and 1. So what it means is that you have 2 digits, but now you are asked to express anything with the 2 digits. So now imagine that you want to say 250, but the only digits that you have is 0 and 1 to explain it. So it means that everything you're going to say is going to still be within the 0 and 1, 1, 0, 0, 0, 1, 1, 1, 1. So that's the binary system, and that's the computer language. Computer uses the binary system. Now, it doesn't mean that because it is just 0 and 1 that everything is just 0 and 1. No, it can use the 0 and 1 to express anything. The only thing is that it only has the 0 and 1 as the limited digits that it can use to express anything. There are other kind of base systems. For example, you have the octal, which is just about 8 digits for you to be able to express 0 to 7, because 0 is one digit, so to 7. So that's 8 digits together. That's the octal. The one we use, which is the base 10 generally, is the decimal. All right, so it's the decimal base system. We also have the hexadecimal, which is about 16. Okay, you have the 16 different digits to be able to express, which is 1, which is 0 to 9, and then A to F. Are you seeing it? A to F to make up the 16, all right, different digits that you can use, and that one is called the hexadecimal. So the whole idea is, think about it, that you have these limited tools or digits, all right, and with these limited digits you can use it to express anything. So if, let's say, I have 256 as a number and I want to express it, I'll just say 256. That's naturally base 10, the decimal base system, 256, fine. But what if I was to express it using base 6? Think about that. It means that I have a limited digit to be able to express 256. So this time around, it's not going to look like 256 again, because the way I'm going to number it, all right, the way it's going to be expressing 256 will not be 256, because it is not base 10. So the purpose of this particular class is to be able to help you, first of all, understand what this whole limit thing is, the whole base system, and then to be able to make you convert. If something is in base 10, for example, you can convert it to another number that is in another base. But it does not change the number. That's the thing. So if, let's say, I have 26 base 10 and I'm to convert it to base 8, it's going to give me a different figure. But that figure in that base 8 is the same thing as this figure in base 10. All right, so let's assume that you are told to convert 25 base 10. Now, naturally, if you just say 25, natural 25 that we know is actually base 10. It's just that we don't always use to put base 10 because it's 25. We know it. We know that it is base 10 that we do our calculations. So let's say you are given 25. It's okay. This is 25. We know it as 25 when we're calculating it using our base 10, which is a decimal base system. But now we want you to express this 25 in base 8. Just think about it. It's 25, but now we want to, or express it in base 6. It's 25, but express it in base 6. How are you going to express 25, which is our natural 25? But if your limit is 6 digits, how will 25 be represented? That's the whole thing. It's actually very interesting. So the first thing you need to do is to do your long division. It's a very simple thing. You put the 25, all right, and then you put what you're to convert it to. Remember, this is converting from base 10 to another base. So let's say you have the 25 and then you have the 6, all right? Now, 6 into 25, how many pieces of 6 can give us 25? If you look at it, 4 pieces of 6 is going to give us 24. So we'll say 4 pieces of 6, 4 remaining 1, because remember it is 25. If it were 24, we'll just say, 6 into 24 is 4. We'll just put 4 and move on. But it is 6 into 25. So 6 can fit into 25 4 times, remaining 1. So we'll put 4 remaining 1. Now, the next thing is we'll bring the 6 again. We'll say, can 6 go into this 4? Are you seeing it now? Now, 6 cannot go into the 4, so we'll put 0 because 6 cannot go into 4. So we'll now put remainder 4. Are you seeing it? Because the 6 cannot get into the 4, so it is going to be remainder 4. So 25 base 10 is going to be 4, 1 base 6. Remember, you have to count it downward up. That's the way it is. So 25 base 10 is equal to 4, 1 base 6. Now let's say you have 31 and you have to convert, 31 base 10, all right? And you have to convert it to a number in base 2. Think about it, base 2. Meaning just 2 digits, the 0 and 1, binary. So you have to convert 31 to a number in base 2, all right? So how do we convert 31? Same thing, we'll go to our stuff, we'll put our 31, and we'll put our 2. 2 into 31, how many times? Actually, 2 times 15 will give us 30. So we'll put 15 remaining 1. Or B, because it is 31. Are you seeing it now? Then we'll say, okay, 2 into the 15. How many 2s will fit into 15? We realize that 2 times 7 will give us 14. So 2 into 7, remainder 1. Are you seeing it now? Why are we putting the remainder 1? Because 2 times 7 is going to give us 14, not 15. So we'll say, okay, we have achieved that it can enter about 7 times, but to remain that 1. Remaining that 1. So we'll keep that 1. Then we'll now come into, okay, how many 2s can get into 7? Are you seeing it now? So how many 2s can get into 2? We realize that, okay, 3 2s, okay? 2 times 3 will give us 6. So into 3 places, all right, remainder 1. Are you seeing it? Then we'll check again. How many 2s can fit into 3? I mean, how many 2 can be inside 3? There's only 1 2 that can be inside 3. Remainder 1. It will be 1, remainder 1. Then we'll now come to the 1. It's okay, how many 2? You see, we have to keep on doing the 2 into this, 2 into this, 2 into this. So how many 2s can fit into 1? None. So put 0, remainder 1. So when you look at it now, 31 base 10 to be converted to a number in base 2 is now going to give us 1, 1, 1, 1, 1 base 2. So to express 31 that this is our natural 31. If computer want to express it, because computer is using the binary, it's going to express as 1, 1, 1, 1, 1. Something like that. So that's how to convert from base 10 to another base. You just use the long division, and when you get the answer, you use the remainder and count it backwards. That is, count from bottom top and write it to the base of that thing that you divided it by. All right. So this is the end of today's lesson. The next one will be how to convert from another number to base 10. It's completely a different calculation entirely. Thank you very much for watching, and bye for now.